Hi everyone, welcome to my new video on creating end-to-end big data pipeline. So if you want to have real-time experience in doing a big data project, this is the right video for it. I'm telling you, if you follow along with this video for 2 hours, then you can manage any big data project. So let's understand the project first. Let's say we have a company which wants to migrate a database. Their data is in Postgres AWS RDS instance. Name of database is PinnacleDB. We have got tables in here like fact order, store info, product info, and customer. Basically, we have e-cart business and we want to migrate this database. And now certainly if it is a real-time project, data will come from various sources, not just this Postgres. We have customer related data coming from one more source, let's say Google PubSub, and we have a store and product related data coming from one more source, let's say some manual CSVs there. And what is our objective? We have to create one-stop platform to have all the data from various sources. That is, we have to create our own data warehouse. We have to migrate all these data to our data warehouse, and on top of which this company wants to create some report. Our tables should be updated at hourly basis, and we have to create one extra table. Let's name it payment table, using these tables in data warehouse and do some operations on it. This is kind of a common scenario in any big data migration project, like you have to migrate some of the tables, and using these final tables you have to create few more tables on top of which reports are going to be created. And at the end we'll be creating one small dashboard for visualization of, let's say, which customers have bought maximum products from our e-cart, and then give discount to them. Let's see our data architecture. How is it gonna look like? So we have data source in here. Majorly our data is coming from this Postgres. Then we have Google Cloud PubSub, and we have manual CSV files. So first of all, we'll prepare data lake. We have AWS DMS in here, which takes all data from Postgres and puts it in S3. For data coming from Cloud PubSub, we have Kafka connector, which puts data to Kafka topics, and we have a code which fetches data from there and puts in S3 bucket. And we have one Lambda function, which generates CSV files, which is also stored in S3. From S3, we take data and put it in data warehouse, that is AWS Redshift. And we have a Spark Scala code for this. We'll have all our code written in Python and Scala. Coding and everything will be of industry standards here. And if there is something which is not as per industry standard, I will let you know. All our code will run on Docker containers, ensuring it can run in any environment. And post that, we fetch data to Metabase and will generate reports. All our credentials will be encrypted using AWS KMS and stored in AWS Secret Manager. We have GitHub as our code repo, and deployment process can certainly be automated using Jenkins. I have another video created for it. You can follow that video. I'll be sharing a link for that. Now, first we need to create source database and populate those tables with dummy data. Remember we talked about some source tables like fact order, customer, store, product, and all that. So we need to create those tables and then populate it with some dummy data, write some script to populate it with some data. So go to your AWS account and create one S3 bucket. This will be our data lake. Everything will be present inside this bucket only. Then search for RDS and create one PostgreSDB here. Select PostgreSQL. Pick default engine version. Let's select dev test. Give it a name. I'm giving my PostgreSDB. You can certainly give some better name. Create master password. Make sure you give some strong password. I'm just giving some easy one. Select burstable and T3 medium. This is neither too small nor too big. Rest of the things can go as is. Create database. In some time your PostgreSDB will now be up and running. Yep, now it's available. Now to pick delta records from this source DB, fetch it through DMS or Kafka Connect, one needs to make some DB related changes. And in AWS RDS, we do this using parameters group. Let's go there. Pick your database engine. Give a suitable group name and proper description. Create. Now in parameters, search for RDS force SSL. Set it as 0. Search for logical replication and set RDS logical replication as 1. And wall sender timeout, set it to 0. Click on that parameter group and select compare. You can see parameters for which you have made changes. Now go back to your database and modify it. Go to DB parameters group. Select the group you created right now. Continue. Apply immediately and modify DB instance. Now refresh it. It will start modifying. Wait for a few minutes. And when it is available, you can see the status pending reboot. So go to actions and reboot. And your DB will now reboot. Once it is available, yep, you can see the new parameter group is in sync. Now go to configuration and copy the endpoint. Open dbeaver. If you don't have, then install it. I have put the link in description. Paste that endpoint in host section. Give username and password, whatever you said few minutes back, and test connection. Okay, looks like there is some issue. You can whitelist your public IP by putting in this security group. This was the issue, I guess. Click edit inbound rules. Search what's my IP on Google. And copy this IPv4 address. Convert it to CIDR format, and if you don't know how to do this, you can Google or ChatGPT how to convert your IP address to CIDR format. Now whitelist just this IP for just port 5432. And then go to your database. Modify. Scroll down. Yeah, in additional configuration, click publicly accessible. Continue. Apply immediately and modify DB instance. Now do the same thing and try connecting again. Yep, this time we are successful. Now let's create our source DB. Run this command, create database Pinnacle DB, and your database will be created. Now you go to edit connection and update your DB name to Pinnacle DB instead of Postgres. Oh, okay, I wrote it in uppercase. Remember, it should be in a small case only. Click OK and connect to this new DB. Yeah. Now create schema, this ECART schema. And then we'll create all these port tables. Let me refresh it. We can see all four tables are present in this schema. Now let's see how to populate these tables with dummy data. I have created a separate video just to populate table with dummy data. If you want to understand in detail, you can check. I provided the link in description. And this code is present on GitHub. You can clone the repo and use it. And please go for eCart v3 as it not only populates data but also updates and deletes some of the rows, thereby simulating as is prod-like environment. Open in terminal. You change this to correct host name, whatever you have for RDS uh, Postgres. Let me copy it from dbeaver and paste it here. I already have Docker file inside eCart v3 folder. Just do Docker build. Then Docker run my eCart data generator. Now the moment it starts running, it will even start populating data in your tables. Let's go to dbeaver and do select a star. You can see data getting populated and keep running this select count star. You can see the count is increasing. After every time we are doing, count is increasing. Let me check some other table also. Yeah, we can see count of each table is increasing. So yeah, this code is working perfectly fine. Let me stop it for now. Now we have to use AWS DMS to put this data in data lake, that is our S3, and then keep fetching delta records. Let us do that setup. I'll be showing you incorrect way first. We will do it the right way after some time. Go to AWS, search for database migration service, go to DMS. First create replication instance. Give it a name. I'll keep things default. We will just select dev test. Create replication instance. Now create endpoints. First we will do source endpoint. Let's select this as our source is RDS-DB instance. RDS instance, select name. Give any suitable name as endpoint identifier. Give server name, username, password. Provide database name and then test it. After some time, status will change to successful. Yeah, now create endpoint. Next step is to create target endpoint. Since we want to put this data to S3 bucket, let me name it as S3 data lake endpoint. Target engine we will select as S3. Yeah, for roles we need to go to IAM. Go to roles, create role. Let me select DMS from here. Next, let me give it Amazon S3 full access. You can give just write access to that S3 bucket in your production environment. Enter suitable role name. And then create role. Now copy the ARN ID and paste it. Give the bucket name. Let me copy it. Paste it here. Okay, so we need to create folder in bucket where we want to store all this data. Put that folder name here. Create endpoint. Okay, since I didn't test it there, you'll have to test it here. Run test and it should be successful. Coming to next step now, we have to create database migration task. Remember I mentioned we will do the wrong way first and then we'll switch to the correct way. So this is the only part I was talking about. It's not wrong, but certainly not the best way to go for. We'll fix it after a few minutes. Create task, give a suitable name, select replication instance, select source and target endpoint you created right now. Change this to migrate existing data and replicate ongoing changes. In table mapping selection rule, provide a schema name and tables you want to fetch data. If you want to select all tables, just let it be as percent symbol. Let me mention a schema name ecart and table will keep as is. Create task. Now start your Docker container to insert dummy data to source tables. Let me check if data is getting inserted here. Yup, it is. Wait till the migration task is completed. It takes some time. Yeah, now it is running. We can see it says load completed and replication ongoing. Go to table statistics. See, for all tables, it will show you how many rows are getting inserted, updated, and deleted. Refresh it, and numbers will increase. Yeah, now go to your S3 folder, ecart. You see load00.csv. This contains first time load, and post that, all the delta changes are coming in this timestamp format. Similarly, for all the tables, you wait for some time and keep refreshing. You will see another set of delta records are fetched, and these numbers will keep changing. Yeah, this step is now completed. But Postgres was not the only source. We had data coming as manual CSV files also. Let's simulate that. In eCard v3, you will find manual CSV generator file. This generates CSV files with product and stored info related details. So you can run this file in local, but we not only have to create it but also send it to S3, as you can see here. Using Faker library, we are generating fake data. This lambda handler is the function which lambda function looks for. This is a function which gets invoked. Copy this code. Go to lambda. Give a function name. Let's say CSV auto generator. Select Python. Create function. Paste your function here. Deploy it and test it. Okay, it is unable to import some of the libraries. To fix this issue, we will have to do pip install inside folder only and add that file as a zip. Let's quickly do that. Create a directory, create Python file, Copy the code and paste it here. Open it in terminal. Do pip install faker -t space dot. It will install libraries in this folder only. You can see everything got installed here. Also in your code, you make sure you have changed it to your bucket name and your folder name, whatever you have created. Now select all these files and compress it to some zip. Now no need to add any code here. Click upload and upload that zip file. Now test it. Give any event name and test it. Okay, it failed as it didn't allow to write in S3 bucket. Go to configuration, permissions, edit it. Go to that role. Yeah, you can attach policy here. I'm giving S3 full access, but you can just give write access to that folder. Save it. Now test again. Yeah, this time it is successful. Go to your bucket and you can see CSV file is generated here. It will be generated every time Lambda function is triggered. So we can schedule it using Amazon Event Bridge. Search for Amazon Event Bridge. Create rule. Name it something like load CSV to S3. We want to schedule it. Let me set it as recurring schedule. Put a star, 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 and this will trigger every minute. So based on your requirement, you can change it. Next, select AWS Lambda. Select Lambda function you want to invoke. Click next, next, and create a schedule. Now go to your S3. CSV manual and refresh it every minute. Every minute you can see a new CSV will be added here. Yeah, so this step is also completed. We had one more data source, that is Google PubSub. Open your Google Cloud. Inside analytics, you will see PubSub. Go to topics, create topic, give a name. I am giving customer info. Create new schema. Give your schema depicting column names and their data type. Validate it. Give a schema ID and create. Yeah, now we have to go to topics again, create topic, again give topic ID. Make sure you select this add a default subscription. Select use a schema. Select the schema you created right now. Create it. Now you have a topic created. Also you have the subscription to that topic. Go to message, publish message. Now let's give a random message and publish it. You can see we are not able to do as it is not as per the schema we provided. Let's give the message as per the schema. Now publish it again. Yes, it's published. Go to subscriptions, go to messages. Since it's a pull based, so we need to pull the message present in topic. And yeah, here you can see we are able to pull it. But for our project, we're gonna be pulling these in our Kafka topic through Kafka Connect, and then we will store it in S3. So go to the code. Inside Python utility GCP folder, you have this GCP pub.py file. Let me try sending data from here instead of directly from Google PubSub. Change customer ID to 12346 and run it. It says process finished. Now let's pull it and we can see the messages here. But this is just one record. I will change it to some random data generator which keeps streaming records to this topic. This same code will generate fake data and publish to that topic. Will generate customer ID through this function. Customer name and customer address through this fake library. If you run this code, data will be populated in Google topic and it will keep getting populated till you interrupt it. Now, as per our architecture, we have to bring that data to Kafka and then to S3. So create one VM instance in Google Cloud where we will create Dockerized Kafka cluster. Give it a name, Kafka instance. Select end-to standard. Allow HTTP traffic. Now create it. Wait till this is up and running. Open PuttyGen. If you don't have, then please install it. Generate public key by randomly moving your mouse. Give username. Click on Kafka instance. Edit. Go to SSH keys. Add item. Paste it to save it. In Putty, click on Save Private Key. Now you copy this host name and open Putty. This is a different Putty. That was PuttyGen. This is Putty normal to log into other terminals. Give host name. Go to SSH auth credentials. Provide credential ID and open it. Give your username here. Now do nano docker compose YAML. Copy this docker compose file here and paste it. Do cat. Just one change which you need to make, replace this localhost with your VM public IP here. Now install Docker and Docker Compose in your VM. Go to this Docker official page and you just have to follow the steps and Docker will be installed. Do Docker PS. Okay, so give access to everyone to run Docker commands, or you can limit the access based on your requirement. Do Docker PS. Yeah. Go to folder where Docker Compose YAML you created is present. Yeah. Do Docker Compose up. It takes some time, and your Kafka cluster, Kafka Connect, Kafka UI, and schema registry all will be up and running. We have things up and running. Just one issue is there, which I have already fixed in backend. So nodes are disconnected because in my Docker Compose I have kept as localhost. Make sure you change this localhost to your Google public IP. I'll be providing correct YAML, correct Docker Compose YAML anyways. I'll replace it with VM public IP, and then it will be up and running. Yeah, this time I ran Docker Compose with -d because I don't want logs to be generated here, so that it runs in backend. Now you go back, get your public IP. In Kafka instance, go to view network details. In firewalls, go to default allow HTTP and add your IP in CIDR format to allow access for port 8080 and 8083, which we will need for Kafka UI and Kafka Connect. Open Kafka UI in local. You can see one cluster is online. And we have 3 brokers and we have some default topics present. Now we need Kafka Connect. We can see in Docker Compose file it is running on port 8083. Open Postman, and if you don't have, then please install it. Yeah, go to port 8083/connectors. We can see it is connected as the status is 200. Now this step is specific to Google PubSub connector. So if you have data coming from different source, you will have different setup for that connector. So if you are like following along with the course, make sure you watch closely. You go to Google Cloud, IAM, service accounts, create service accounts, give it a name, select role, search PubSub service agent, continue, done. This is the role created. Go to permissions, grant access, select your service account and give Google Cloud PubSub service agent role. Save it. Go to keys, add key and it will get downloaded. Oh, okay, I forgot adding one more role. So go back and add editor role. You'll have to save it again. Go to Kafka instance and put this JSON file there. Now inside docker cp command, you need to copy this file inside docker container Kafka Connect. Go inside the container using exec command, and you can see file is present here. In your postman, in your request, give proper path inside container as it will need this file. This is the path inside the container. This is your connector name, class for Google PubSub, give topic name, Google project ID, PubSub topic ID, subscription path, credential path, bootstrap servers, and application factor. Click send request, and you can see it is successfully created. Go to Kafka UI again, and you can see Kafka connector is running. Now run this GCP pub file, and it will start populating data in GCP topic, and you will even get to see in your Kafka topics through Kafka UI. And we can see data is generated, and through Kafka Connect it is coming to our Kafka topic. Refresh it, and more data is coming. Now we have all sources up and running. We now have data in all the sources. Let us first handle this data which is coming from Kafka topic and put it in data lake. This is my Spark Scala project. Go to build SVT and add this Spark SQL Kafka. But to ensure how it runs, go to your Spark folder where you have downloaded and installed Spark. Inside Spark bin, make sure you have this winutils.exe if running in Windows, and then ensure you have this hadoop.dll present there. Then come back to project. This is my folder structure: Scala, com, my company name ITS, then project name eSales. These are different folders here: batch, framework, services, streaming. Inside streaming we have Kafka, inside which we have consumer. And to run all this, we have framework, jobs, controllers. Then base controller, which has this Spark session. We will be writing code and discussing in detail about all this. We have controller to run each function, to run each class. For example, this customer S3 ingester is to run this customer S3 ingester class. We can edit parameters and configs here if we don't want to use existing base controller as Spark session. We have this trait job which has logger method. We're gonna be changing it in some time. Inside job enum, we will have list of all batch and streaming jobs, and we can take a look of all the codes which is running in this project. Job factory takes detail from job enum and create jobs. Now our actual code is written in here. We have our class customer S3 ingester. Here the Kafka servers. Make sure you have whitelisted your IP for these ports too in Google Cloud, 9092, 9093, 9094. I'm not showing that here. Now give that Kafka topic name. Put all these things, starting offsets, checkpoint, and path. But first I will just try to print it in my console. So set format to console. Let's open Kafka UI. Go to topics. Okay, I have restarted that container, so let me recreate that connector. Here I made one small change. I replaced Kafka 1, Kafka 2, Kafka 3 with the public IP, but both will work. And yeah, connector is running. Let me start this GCP pub again, and data will start getting populated in Kafka topic. Yep, it should be started. Yes, here is the topic. Go to topics, reload page, and here it is. You can see messages getting populated here. Let me run this and print it in console. Go to controller and run that. You can see we are able to consume data from topic and display it on our console. Now I will try to load it in S3 bucket. I'm giving credentials here for now, but later I will tell you how to encrypt and encode and then put it in AWS Secret Manager. But for now, set your access key and secret key. Make sure you have got access to write on Amazon S3 for these access key IDs. So the weird JSON which was coming there, this regex code is gonna parse it and write as per the schema. I have commented this console part and uncommented this part to write data on S3 in Parquet format. This is the path where data is gonna be stored. Let me run it through controller. And here we have data coming in our S3 folder in Parquet format. As long as it is running, Parquet files will keep getting appended here. So we have manual data coming in our data lake. Yeah, so we have manual data coming in our data lake. Data from Google sub is coming in our data lake. And data from DMS is coming in data lake. Now one thing to note here is that for manual CSV and Kafka we have written the code and we can even partition the data based on year, month, date, hour, etc. Because we have code written for it, we can write it in any way. But this is not the case for DMS now. We will have to tune it. So now this is what I was talking about before and that we should improvise our DMS tasks. You see, as of now, we have got few files in here. But in just one day, we will have like thousands of files and then millions, and reading all the files and then filtering it is a very expensive operation. So it's better to partition files based on timestamp. Also, these files are in CSV format, which is not a good file format to save data as it takes too much of storage. So it's better to save in Parquet format. Let's do that then. Go to DMS, endpoints, S3 data lake endpoint, modify. Remove CSV row delimiter, CSV delimiter, make data format as Parquet, data partition enabled should be true, and here do confirm this data partition enabled is true because sometimes even if you set as true above it remains false. Also, add column name should be true. Now save it. Yeah, I'm telling you, please check again if data partition enabled is true only. Now go to database migration task. Let me delete this existing task and create it. Create task, give a name, choose endpoints. We are repeating, but we'll make one small change here. In table mappings, choose a schema. Ours was eCart. Now go to JSON editor. Now after this, we want to add a column which is always increasing transact ID so that we will know which event occurred first and which happened later. Copy it and paste it here. We will know about all this later when we see the data and the code. It adds 35-digit number which is always increasing. First 16 digits is timestamp and last 19 digits is a record ID number. Now before creating task, I assume you have deleted that folder from bucket where we already had stored data. If not, then please do it. This will again start capturing data and storing it in that folder in bucket with these changes. So our task is now creating. It will take some time. Let's wait. Yeah, now it's created and load is completed. Let's check in S3. Go to that folder. You can see our full data is loaded in this folder in Parquet format. Restart your Docker container and it will start inserting, updating and deleting data. Let's check if count is increasing. Yup, it is. Now refresh your bucket folder. We can see data is present in folder wise structure. This is year, then month, then date, and then hour, and then we have this file. You can go to DMS endpoints and change folder structure based on your requirement. For example, you might not want hour level partition, so you can just remove HH. Now let us read these records. This is initial record and CDC records from the bucket. Initial load starts with L and CDC is in this timestamp type folder structure. Just read it and see how data looks like. Let me correct dates and read it. This is load.parquet. You see we have extra column transact ID but no init data as it is initial load. And this is CDC data and we have this increasing transact ID. So you can see the first 16 digit is timestamp and the other is record number. And the first column OP denotes if record was inserted, updated or deleted. So now we have completed our data lake layer. Now let's see our data warehouse. Go to Amazon Redshift, create work group, give it a name. I am giving test work group. Next, give namespace name. Click customize admin user credentials. Manual add admin password. Next, and create. Now you can see your namespace is available. It is publicly not accessible. Let me change it. Turn on publicly accessible. Refresh it and it will be on. Copy this JDBC URL. Go to dbeaver, new connection, search for Redshift. Give your URL here. Put your username and password which you just created. Click test connection. And yes, it is connected. Open SQL editor. You can write your queries here. Go to AWS, query data. In your test workgroup, give a database name dev, admin, password, save it. Now you can create your own database. So let me change it to ITS. Let's name it ITS. In database user, select admin, refresh it, and you can see the database. Create a schema. First one will have all the delta records. Let's name it CDC, and other we will have ECA target. Create it. CD tables will have a schema of source table. Just add that OP column in it. You can create all the 4 tables. I will focus on CD customer and fact order for now. Create this table. Now create other tables too. Now create final target table where you want to migrate the data. You can have a schema as per your requirement. You can change column names or keep it as is, or whatever your business asks. I'm keeping column as is. Create these target tables. Write this Scala code to check if you can connect to this Redshift. Yep, we can see it's connected. Now, for initial records, since no any transformation required, you can directly read it and append in target table. Or you can do transformation and then load it to ECA target table directly. As of now, just for development purpose, code is like this. After some time, we will organize it and make it as per industry standards. For CDC, you need to read the data and then do group by on primary key and get the latest changed record based on most recent transact ID and put it in CDC table. Run this code and data will be loaded in CD tables. Now you need to merge CDC tables with ECA target tables. This is the code to do that, and this is basically a CD1. Just FYI, there is a small mistake in code for few use cases which we will fix later, but this time count has matched. So for all the small features which we are testing, I have created these objects just for testing purpose in this test folder. We will be organizing it later. This one is to read Parquet as we saw. This is for connecting to Redshift, our data warehouse. Now with this code we are reading initial records, then fetching latest delta records and then writing to ECA target tables. Since the CDC part we're gonna be running every hour or every day based on the requirements. But every time we are running, we need to ensure we take data greater than the last record which was already processed. So we need to store somewhere the last transact ID already processed. Go to DynamoDB in AWS to store this info. Create audit eCart tables. Give partition key as a schema name underscore table name. And then just create table. Name of the table is audit eCart tables. Go to actions, create item. Give the name in this format. eCart is a schema and customer is table. Create item. We will add one more item. Last read transact ID. And we'll set that as a -1. Save it. And you have this row added. eCart customer with the last read transact ID as -1. We have this object also created in test code section. Connect DynamoDB. Just make sure this access key can access DynamoDB tables. Provide region. Create DynamoDB client. Put the table name here. Put the partition key here. Now do the query request. Check the table name for which you want to see transact ID present in audit table. Now, if the table name is not present in your DynamoDB document, it should create that item. Create that item with value as -1. And if it already exists, you need to get the value associated with that table name. Now run this. Yeah, and it says eCart customer already exists and it gives the details. Now let's see one more function here. We're gonna be merging all codes in some time and then we'll organize it. Now please listen to this important and very crucial step. Let's see if you have to run this code on hourly basis and assume job already ran at 11:30. Now it will run at 12:30. In S3 we will have folders for both 11 and 12 hour. We won't be checking files from this 12th hour folder only. We need to take 11 also. Why? Because let's say we ran our job last at 11:30, so data coming from 11:30 to 11:59 will be inside 11th folder only. So whenever we are running any job, we need to understand if it is hourly job, we're gonna run for this hour and last hour. And if it is daily job, we need to run for today and yesterday so that we do not miss any data. So here I am hard coding values 11 and 12. The base directory will remain same. We will be writing this properly using current time and last hour time in some time. For now, let's see with this hard coded values. Now read data from these two folders. This is the code for that. Put both folders in this read method. So we got data from both folders. Next step is to remove these hard coded values 11 and 12. We will be reading it based on current time and last hour time. Get all these details. Put them in file pattern 1 and file pattern 2. And then read it. Also, it is possible that data might not be present in one such folder. For example, no data came in current hour folder when the job ran. Then it will throw error. So we need to have this if-else logic to first check if file exists in that folder and then read it. Now let's merge all our code and see step by step. Provide DynamoDB client and give table details. Create here. Check if table exists in DynamoDB document. So it goes inside this loop, which means it doesn't. This is the first time load. It says table not found. Now it has added table name in DynamoDB with value as -1. You can see here. The first time this data will go directly to target tables. We are not doing any transformation, but you can based on your use case. Provide the JDBC details, truncate the existing target table and then reload it. You can see table is now truncated, and then it will do initial load from that load 00001.parquet. If any transformations required here, you can do that. Wait for some time and data should be loaded now. Yeah, here it is. Also, after initial load, I am changing this audit table last transact ID to 0. Now you need to read all the delta parquets that got created till now. And post this run, you can run only on hourly basis. Now read all the records, and delta records has to go to CD tables. Let's truncate CD table first. And then put these records in CD tables. Now, since we have processed our delta records, we need to update our audit table with the latest transact ID. Get the max transact ID from the delta records. Now this value is updated in our audit document. Let's check it. Yeah, here it is. Now records which are in CDC tables have to go to target tables. We need to merge these two tables. This is my query which we discussed few minutes back, and it had some issues for few records as I mentioned earlier. Run this and data will be merged to target tables. Now let's go back to our code. What we ran just now was for loading the data first time. But from next time onwards, after let's say we schedule it on hourly basis, it will just take delta records of this hour and previous hour. Let's do that. Let me minimize this. Most of the code will be similar. Run it in debugger mode. Set properties for Redshift. Yeah, this partition key already exists. Get current hour time and previous hour time. Make sure the time zone of S3 and the code is same. And ensure time format is proper, as let's say if month is Jan, then if you don't format it properly, it will take month as 1 instead of 01, and then it won't be able to find that folder. You will get this hour and last hour. Get the last transact ID from audit document. Now again with similar logic, you have to read data after checking if file exists, and then filter it based on transact ID so that we don't process same records multiple times. Do group by, aggregate, get latest record based on transact ID for each primary key, and then write it to CD table. Post that, we will run our merge query. To merge CD table to eCard target table, this is the same code with which we can merge our CD table to eCard target table. We can see our Scala code works perfectly fine, but it is very cluttered here. Let's try to standardize it a bit. Here in util folder, I have created class for each of these utility which we are using so that it can be utilized anywhere in our code repo. We have DynamoDB, JDBC, Redshift, S3. These are the methods for everything you wish to do for our DynamoDB document. You can have a look. Like this function can be used to insert records in DynamoDB document. This is to check if that partition key is available or not. This checks total count of that primary key. And if it is 0, it means this doesn't exist in our document. And this will extract record associated with that hash key. Now you can use this Scala object test classes to test each of the class and its method. Just come to this test class and uncomment whichever class you wish to test. Here I am passing AWS access key and secret key, which is certainly not the right way, and we will fix it later. Give all the details and create handler object. And you can test all these methods. Similarly, to test JDBC class, you can use this code using JDBC handler and the Redshift class. Like if you want to execute some query or fetch records from Redshift, you can use this. And then S3 handler to connect to S3 bucket and do various operations like checking if file exists, or reading multiple Parquet, reading single Parquet, read CSV, read multiple CSV. We can do all this. You can use any of these methods anywhere in your code. Now this entire messed up code, let me declutter it. Remember, this code is still not as per industry standards. Just that util folder we created right now is as per the standards. Let's put all the details here. Create all the handler object using the class present in util folder, and perform all the operations from here using methods already created. And this is the code we usually run after loading delta records to CD tables. And we're gonna be including this in code as well. Yeah, here we have written all these SQL code. Just one problem here is that the values are hard coded for customer table only. Now for standardizing our code, you need to ensure that you have added these logger related dependencies. We're gonna be using it in our code. Assign all these properties so that we can see which file is giving what error. Now all my code for these batch processing will be inside Scala com its esales batch folder. We have code present in util for all our helper function we just saw right now. We will be creating folder inside this batch for all the ETLs. This is one such customer folder where we will write the ETL for customer. And as already discussed, we have this controller folder where enum file is there to list all our jobs, job factories to create jobs. And for now, I'm creating customer object so that I can run it from here only. But otherwise, ideally this object is to be present inside controller, and we will have class in here, just like we saw for streaming Kafka. We will fix this later. Customer contains all the detail specific to this customer ETL only. Remember again, we are giving all these passwords and all here, which we will fix it in some time. And this extends DMS handler. Let's go to DMS handler class. It is present inside common folder. And this class extends batch ETL. This DMS class is specific to the use case where we are fetching data from S3 that comes from DMS, and batch ETL is generic one, and base controller contains that Spark session. These are the methods present in batch ETL, which can be used for any code inside batch, even for data not coming through DMS. You can see generic methods here like reading from S3 and loading to S3 and loading to JDBC. And these all variables are for handling data coming through DMS, which accounts for 90% of the ETLs. You can override these variables for specific ETLs. And there are some variables which must be overridden. These functions ensure that. This method we are calling from our customer object to tell how to run, whether hourly or daily or monthly. Default is hourly, we will see it in some time. Now, whether it should run initial load or delta load, that depends on audit document. If that table name is not present or value is set to -1, it will do initial load. And then we have this function which does initial load, and we have already seen how this function works in great detail just few minutes back. Let me quickly revise it. It will insert record to audit document with value as -1, take initial load from S3 and load it to ICA target tables. Then we'll update audit document to 0. Then it will process all delta records that came till now, read those records, get max transact ID for each primary key and load it to CD table. Trigger those queries to merge it to target tables, and then update audit document to latest transact ID which it processed. This is the query for that, and this is written in generic way. It will be for all the tables, not as specific to customer like before. Just you need to provide column names in your specific ETL objects. This is process load method which has to be triggered here. And if you find that any generic method doesn't help your ETL, you can just override it. This process load method, you can change it from your code itself, from hourly to daily, monthly, or yearly. We have a specific methods written for all of it. These are the methods for each of them. Just the file path needs to be updated. Now, all this was for reading data and loading it to target tables. We have not done any transformation till now. And what if we have to? Let's add transform method in DMS handler. In process initial load, we have this transform bulk load. We can have data from some other source, join this with our existing data frame, or do some processing here inside this override method. This is that transform method which here is taking as this data frame and will be transformed after it is overridden there in that specific ETL. Remember, we have this common method for transforming both initial and CDC records. And the only difference between them is one has got this extra OP column, operation column with IU and D, and other doesn't have this extra column. But rarest of the rare scenario where your transformation logic has to be different for initial load and that of CDC, or your transformation involves OP column, you can override this transform bulk load code. This is gonna transform only initial records. But this will take care of that, but you don't need to touch it for 99% of the scenario. Whatever transformations you have for initial load, the same transformation is gonna be for your CD records. I have created ETLs for all the tables. These are the few things that just need to be changed for each ETLs, otherwise mostly things gonna remain same. Now, if you remember, customer data is not only coming from DMS but also through Kafka. We will write that ETL also inside our customer folder only. This is gonna extend the batch handler and not DMS handler. Similarly, product and related details is coming from manual CSV. So we will have this product stored manual inside product folder. These code can't be handled through generic way. So we're gonna use the methods and write our own specific code to handle such data. Here we have even done some small transformations depending on the use case, loaded it to CD tables and merged it accordingly. Now, apart from usual data migration with transform, we sometimes even have to create reports using these migrated data. Let's say we have to create another table, payment, using tables present in our data warehouse, the final tables. Take the data, do the transformation and overwrite it. Let's say our use case is to give discount to some customers. As of now, I'm randomly giving discount, but your use case can be very specific. Also, product price and sell price, I want to have max 2 digits after decimal. These are few transformations I want to do. Let's create that payment table and we can run code to override the table. And reports are generally overwritten. So instead of load, we have this reload method which doesn't append but overwrite. Now we have been talking about this a lot, removing secrets from code and use encrypted and encoded one. So now let's do it. Open your AWS, go to key management service, customer managed keys, create key. We'll keep everything as default. Give some alias name like eCart migration key. Next. You can give admin or your DevOps guy access to this who can administer this key. Next. Admin user. Next. Finish. I'm not doing it as I have already created one. After some time it will be enabled. Now go to secrets manager. You can store your secret in this format. Environment name / project name. Click store a new secret. Other type of secret. Give name, source DB, password, and then write encrypted plus encoded password. In few minutes, we will see how to convert your password to this format. Click next. Give name in this format, like environment name dev, then / project name. Next. Yeah, things look good here. Click store. Refresh it and it will be here. Now to get the secret values, click on it, retrieve secret value, and you can get it. But for now, for this project, I'll be using this third one, prod eCart migration JDBC-DB. You can remove this JDBC-DB here, as you might want to store all passwords and not just JDBC-DB. This is your secret key and secret value. We will see in a few minutes how to convert JDBC password to this format. You can add few more passwords, for example, target password, write the encoded value here. Now let's see how to come up with these secret keys. Inside util, we have encryption folder in which we have encrypted project. Remember, this file is to be removed from your repo. You're not supposed to keep this file in this project, or if you want, then you make sure you remove this password from here after encrypting it. You put your actual password here and run it. With help of customer master key, which is present in environment variable, I will show you how to put it there. You will get your encrypted plus encoded password and you can paste your password here. Go to decryptor class. You can see we have this decode data method. Because in encryptor we encrypt and then encode it, so in decryptor we decode and then decrypt it. To decrypt it, again we will need customer master key. Go to KMS, click customer managed keys and copy it. On IntelliJ, click edit. In environment variable, write that customer master key like this. Remember, no spaces here. Obviously, you won't be passing that encoded password directly. You will have to get it from secret manager only. This is the method for that. You pass key and secret ID and you will get secret binary string. Then you can call decryptor class to decrypt and decode it. Here we have one more method. Let's say we want to store some data directly in a secret manager without encrypting it. For example, JDBC URL. In that case, we will just want to retrieve data, not decrypt it, because it is already decrypted. Let us see how it works in batch ETL. We have this method getPassword. You provide secret ID here in which all secrets were stored and secret key for which you want value and then decrypt it. And then we have another method for another case where we have just kept some value without encrypting it. We provide same details, just we won't decrypt it. Let's see how it works. For JDBC password, we have get password. For JDBC URL, we have get config. This is the URL which I don't want to keep here. Rather put it in secret manager without decrypting. Let me paste it in secret manager. So here we have URL and secret passwords. Now let's run it. So here we are getting all secrets. Make sure you don't print it in your project. We can see it is able to connect to DB and perform the required operations. Now our code looks good. Just a small issue is there. We still have AWS access key and secret key. Let's put them also in environment variable. Yep, done. Let's run it and it's working fine. Also, instead of overriding AWS access key in every file, you can put it directly here. We have our entire project ready. I have standardized it, took care of secrets and all. I showed you for one product store manual. You can do the same for remaining files. Now to run it, we should use controller and not directly run it from here. So I converted product store manual to class instead of object. Also, I put entire code in this run method. Let me show how it was. So it was object and it extended app. Now what we are doing, we are converting that object to class and remove this with app. The rest of the things will remain as is, just it will be inside this run method. Now go to framework, jobs, controller, base controller, and this product store manual controller extends base controller. Take that job type from job enum, add your class in this job enum, and write this in job factory to create job. You can put your own configs here, update it as per your requirement, and then create job and invoke that run method. You can run it from here. And yeah, please convert all rest of your object to classes and run it through controller. Now let's build our project. Inside project, add this plugins.sbt. Remember, you have to do this inside eCart migration build project. Write this add sbt plugin. And in build.sbt, which is outside, you add this assembly merge strategy. Go to file, project structure, artifacts, click plus, jar from modules with dependencies, select eCart migration build, select main class, product store manual, OK, click apply, OK, build artifacts, clean it, and then build it. You can see jar is created here. Now you install SBT in your system. I've shared the link in description. Open it. See in explode. Okay, so the time is 2052. Now we build it again using SBT. Go to your project, open it in terminal, run command SBT assembly. It takes some time and you can see this jar is updated. Let's see the time. Yeah, it changed to current timestamp. Now all our artifacts we can store in S3 bucket. I have a folder created, artifacts. You can put all these jars there. Let us upload it manually. Yeah, jar is now loaded. Now we need to run our code in container. This is Docker Compose file which spins up container with a Spark image and has master and worker nodes with appropriate memory. We need these three environment variables: customer master key, AWS access key, and secret key, which should be passed through system's environment variable so that underlying code can take it. Now let's create this variable in our local system. I have added access key, secret key, and let me add customer master key. Yeah, now we have all three. Go to your project folder, open it in terminal, do Docker Compose up to spin up containers. So yeah, here we can see master and worker nodes, they all are up and running. Do Docker exec and go inside the container. Okay, since it is Windows, it doesn't work like that. Add this winpty as prefix. So yeah, this is our container with a Spark installed. Create directory myjars. Yeah, now exit container. Using Docker CP, you can copy that jar and put it inside container. Now do this Docker exec to run a Spark submit command inside your container. So my Spark Scala code is running perfectly fine. Okay, we got some error. Yeah, it says that Redshift jar is not available. Go to your code, build SBT. Yeah, we need this Redshift jar. Here it is present in external libraries. Open the folder where this jar is present. Let's see all the jars pre-installed in the Docker container. Yeah, here we can see there is no any Redshift jar. Do Docker CP and add this jar where all jars were pre-installed. Yeah, now check again. Yeah, here we have Redshift jar. Again, do Docker exec and run a Spark submit command. Yeah, this time it worked perfectly fine. Okay, so we are running Docker container in our local only. We should run it in Cloud VM. Open Google Cloud, SSH into your VM. Follow the documentation and install Docker. Then install Docker Compose. Put the Docker Compose file here. Okay, you can see it gives warning as these environment variables are not present in here. Access key, secret key, and customer master key. So let's stop it and add these environment variables. Do source tilde slash star.bash rc to save it. Oh, okay, sorry. I have added these variable for different user and I'm running it through root. Let me add it here. Now do Docker Compose up and you can see no warning. Save it. Okay, we have container with a Spark running, but where is our code? Our jar is present in S3 bucket in artifact folder. We need to copy jar from there to this VM, for which we will need AWS command. So install AWS CLI in your VM, follow this URL link in description and install it. Now it is installed. Do AWS configure, provide your access key here. Now provide secret key. Enter, and you are all set. Using AWS S3 CP, you can copy jar to your VM. Now with jar, container, and environment variables present, it's exact same step as we saw before. You can put Redshift jar in this Docker container and run docker exec command with a Spark submit just like before. I won't be doing it again. So we have now completed our deployment also. Let us see how to generate reports out of it. Here we are using this open source tool Metabase. Follow this documentation and install Metabase. I have provided link in description. Run this container on port 3000. Make sure you whitelist this port for your public IP. Okay, I have whitelisted for all. Yeah, you do it just for your own public IP and run it. Fill the document, create password, select your warehouse. Ours is Redshift. Provide name. Provide host name in required format for your Redshift. Give your port name here. Provide database name. Give your username and password. And connect to database. You can see your database is here. All your schemas are here. Go to target tables. Let's see order tables. You can summarize it for customer IDs. Those who bought maximum number of products, and then probably you can give them more discount. You can change the order here. Save it. Give suitable name here. and save it in your dashboard. Similarly, you can create more report based on your use case using all these final target tables. So that's all for the video. If you have stayed until this point, congratulations. You have taken a significant step in your journey. Pat yourself on the back because you're not the same person who started this video. You now possess a deep understanding of big data pipelines. What once seemed like a buzzword is now a tool in your arsenal. You have the capability to create complex pipelines and tackle any challenge. Remember, the sky is the limit. Go out there and make things happen. And don't forget to join me on these platforms. Thank you.